So have you ever wondered why a lightweight wheel can actually be stronger than a heavier wheel? This is one of those things that we're going to try to tackle today by kind of introducing you to the flow forming process if you're new to it. But if you're not new to it, we want to give you some further explanation to really understand what happens during that process. My name's Scott from KONIG. Let's get into it. So if you're into wheels, there's no doubt that you have heard about the flow forming process, whether it's be from us or through some of our cool videos on YouTube, hint, hint, subscribe, or you have heard about it from other manufacturers as flow forming becomes more popular, and it has. You're starting to see more companies continuously do it. But what does that flow forming mean? When you see a flow formed wheel and it costs a little bit more than, let's say, a traditional cast wheel, is it worth the money? And so we're going to tell you what the flow forming process is, kind of go into some of these things in detail. All right, so what is flow forming? Flow forming in its very basic sense is essentially when we're going to cast a wheel at a narrower width, we're going to then turn the wheel under heat while applying pressure to the barrel. We're going to extrude out the aluminum in the barrel. We're going to compress that molecular structure, which tightens up the grain pattern. And when we do that, we get a wheel that is stronger and lighter. But how do we get there? I just threw a lot of stuff at you real fast. So how we get there is pretty simple. Essentially, what we're going to do is we're going to start out with aluminum. We use A356.2. Essentially, that's a T6 aluminum. And the idea here is that we're picking an aluminum that has great properties for strength, durability, and the ability to have, a lightweight property. And this is a similar material that you'll find used in different aerospace applications, as well as aircraft and some of the areas where they need to have lightweight properties with extremely strong aluminum parts. So again, let's kind of break it down. We're going to show you some video here while we kind of run through this. So here you can see a flow forming machine. You see the heat that's being applied under the wheel. The wheel is spinning, and it's spinning on a flow forming drum here. And what's essentially happening is that's acting as the thing that we're going to press down against. And so the position that you can see behind here is actually a die, and those dies essentially are going to go from the front part of the wheel, where the face would be, and start to extrude out by putting pressure with that die against that inner drum, and essentially forcing that material into a tighter grain structure. And that's what we mean by changing the molecular structure. See, it's the same thing. When you take a forged wheel, you start out and you're essentially taking a block of aluminum, they smash it down with like a 10,000 ton press, and essentially what you're left with is something that's more dense, but obviously more compact in its structure. It's the same thing if you start to think about it, like when you get a hamburger and you get it from there and you want to smash it down. So you take your hand and you slam it into the table. All of a sudden, that hamburger is the same hamburger that you had before, but that bread is not so fluffy anymore. It's really condensed. It's packed tight. The wheel may start out in an 18 by 7.5 when it comes out of the mold, but then we're going to force that flow forming process to extend the barrel out to, let's say, an 18 by 10.5. That's where we want to be. We use that material to essentially extrude out the material and compress that structure. And now we are making the width to the exact width that we want. And by doing that, we're able to use less aluminum. And that's how we get to that question that we asked in the beginning of how can you make a wheel that's lighter stronger than, let's say, a wheel that's heavier? By changing the process of the aluminum and condensing that grain structure, what we're doing here is we're making the wheel have more tensile strength in that part of the wheel. And there's other benefits that come along with the flow forming process. Things like greater shock resistance, right? Which makes sense. If the wheel is going to be a little bit stronger, it's going to be able to take a little bit more rigidity and a little bit more impact based off the fact that it's just a stronger property wheel. Additionally, it's going to have something called elongation. It comes with more elongation. Now, that comes in part also from the 356.2 aluminum that we are using, but also the flow forming process allows a wheel to essentially have more flex property before it would ever reach a catastrophic breaking point. And that's important to know because remember that a wheel in a lot of capacities, especially today with modern day cars where you have stiff suspension and stiff sidewall tires, the wheel has now become more of like a shock absorber than ever before. So we're asking this wheel to constantly, no matter how you travel, take more flex and more stress as it travels down the road than we ever have before. And that is one of those things where a flow form wheel can certainly give you some additional properties that even are found extremely helpful in everyday driving. Here's again is a good example of just showing you some quick dissections of a wheel. Clearly we used a table, so we're pretty advanced over here, you could tell. So what you're looking at here is essentially cut profiles of a given wheel. One obviously is traditionally casted, the other one is utilized with flow forming technology. Don't look at the little bend one, that's after. That's clearly after. But if you look at the two profiles that are kind of next to each other, you'll see that one is obviously a little bit more thick. And the important thing to understand is that this process here, where you're looking at these, cut dissections, they're of wheels that are of the same load capacity. So you're achieving the same load specifications. And again, the flow forming process allows us to be able to use less aluminum. So that's what you can see. The barrel's obviously much thinner. Now, what you are looking at from right to left, just to be very clear, let's look at the flow forming side. From right to left, what you're looking at is how the wheel comes out originally from the mold. This hasn't entered into the flow forming process yet. Now, if we hop again one more step to the left, you can see that now the barrel clearly has become thinner, and it's starting to take the final width that we need for the wheel. But again, what hasn't happened here is the final extruding out and the final machining process. Again, one more step further to the left, you can now see this wheel is at the final width, has been properly machined, and is at the actual thickness that we're going to be striving for. So that same thing happens over here on the traditional cast wheel. Again, comes out of a mold, is much thicker. Then we're going to machine off what we don't need to make the wheel profile that we would obviously desire. And that's kind of it. So you can certainly see the differences in the thicknesses of the final wheels. So that's it. Congratulations. We made it to the end of the video. Obviously, we did you a favor here by not having to look at me on screen. So we hope that you found this very informative. So this answers the question, can a wheel that is lighter in weight be stronger than a wheel that is heavier? And so today we have answered yes, and we've explained why. If you have any other questions about this or the flow forming process, go ahead and drop them below. We appreciate you subscribing, clicking that like button, and throwing a comment in. We try to answer all of them, and if we miss your comment, you can always catch us on Instagram or Facebook live at 2 p.m.
Another
on Wednesdays, where we go
Yeah.
live to answer all your questions. Take care of yourself. We'll catch you on the next one.